Hello students, in this video I will discuss molecular orbital theory, which gives us an idea about the magnetic properties of compounds, and also it explains the stability of any particular compound. According to this theory, the electrons in a molecule are present in the various molecular orbitals as the electrons of atoms are present in the various atomic orbitals. As we know that in an atom, various atomic orbitals are present around the nucleus of the atom. Similarly, this theory suggested that many molecular orbitals are present in a molecule. Second point, the atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. As valence bond theory suggested that only valence electrons or valence atomic orbitals participate in bond formation, but molecular orbital theory suggested that all atomic orbitals of combining atoms combine with each other according to their symmetry and their energy. For example, 1s orbital of an atom combined with 1s of other atom, 2s will combine with 2s, and similarly 2p combined with 2p. Third point, while an electron in an atomic orbital is influenced by one nucleus, in a molecular orbital, it is influenced by two or more nuclei depending upon the number of atoms in the molecule. So as one electron in an atom is influenced or it is in attractive force of nucleus, similarly, according to this theory, electrons of a molecule are in attraction of all the nucleus of all the atoms which are present in that molecule. Thus, an atomic orbital is monocentric while a molecular orbital is polycentric. Fourth, the number of molecular orbitals formed is equal to the number of combining atomic orbitals. That means, if two atomic orbitals are combining to give molecular orbital, then we get two molecular orbitals. If three atomic orbitals are combining, then we get three molecular orbitals. When two atomic orbitals combine, two molecular orbitals are formed. One is known as bonding molecular orbital, while the other is called as anti-bonding molecular orbital. Fifth, the bonding molecular orbital has lower energy and hence greater stability than the corresponding anti-bonding molecular orbital. Sixth, just as the electron probability distribution around a nucleus in an atom is given by an atomic orbital, the electron probability distribution around a group of nuclei in a molecule is given by molecular orbital. So we can say that as atomic orbital is a probability area for electron around the nucleus, in the same way molecular orbital is also probability area for electron around nucleus of all the atoms of a molecule. Seventh point, the molecular orbitals like atomic orbitals are filled in accordance with the Aufbau principle, obeying the Pauli's exclusion principle and the Hund's rule. So all the rules according to which electrons will enter in atomic orbitals, electrons in molecular orbitals also enter accordingly. Now molecular orbitals are formed by atomic orbitals by a process which is known as linear combination of atomic orbitals, or in short it is called as LCAO. For this, molecular orbital consider wave nature of electron. As we have discussed postulates of molecular orbital theory, if two atomic orbitals combine, then two molecular orbitals are formed. One molecular orbital is known as bonding molecular orbital and it is related to lower energy level, and one is known as anti-bonding molecular orbital and it is associated with higher energy as compared to energy of atomic orbitals. Okay, so we can say that 50% of molecular orbitals which are formed are of lower energy and 50% molecular orbitals are of higher energy as compared to combining atomic orbitals. Now let us see that how bonding and anti-bonding molecular orbitals are formed. 1s can combine by two ways. Addition of 1s atomic orbitals give bonding molecular orbitals, and subtraction of 1s atomic orbitals gives anti-bonding molecular orbitals. Addition means this gives more electron density near the nucleus. Anti-bonding means, or subtraction means, by this electron density becomes weaker near the nucleus. Similarly, 2pz combine and we get bonding and anti-bonding molecular orbitals. 2py and 2px also combine and we get bonding and anti-bonding molecular orbitals. The molecular orbitals that we get by s atomic orbitals and pz atomic orbitals are called as sigma, and molecular orbitals formed by combination of px or py are called as pi. Okay. Now bonding and anti-bonding molecular orbitals are represented by symbol sigma, sigma star, means this is the symbol for bonding molecular orbital and this is the symbol for anti-bonding molecular orbital. Similarly, these are represented by pi and pi star. Okay. As two electrons can be accommodated in an atomic orbital, in the same way, two electrons can be accommodated in one molecular orbitals, not more than two, and two electrons remains there in one atomic orbital with opposite spin. Now let us see the energy sequence of various molecular orbitals. This is the energy sequence for all the molecules except boron, carbon and nitrogen molecules. So electrons will fill in these molecular orbitals in this sequence only. For boron, carbon and nitrogen molecules, energy sequence is this. Difference between these two is only at this level. For boron, carbon, nitrogen molecules, pi 2px and pi 2py lies to the lower energy side as compared to 2pz. Now let us understand some terminologies that help us to understand stability of molecules according to molecular orbital theory. If Nb is the number of electrons occupying bonding orbitals and Na the number occupying the anti-bonding orbitals, then the molecule is stable if Nb is greater than Na. That means if number of electrons in bonding molecular orbitals are more than electrons in anti-bonding molecular orbitals, then molecule is said to be stable. And if electrons are more in anti-bonding molecular orbitals than bonding molecular orbitals, then molecule is unstable. Next term is bond order. Bond order is defined as 1/2 the difference between the number of electrons present in the bonding and the anti-bonding orbitals, and formula for bond order is this. Next is bond length. The bond order between two atoms in a molecule may be taken as an approximate measure of bond length. Okay. The bond length decreases as bond order increases. That means bond order and bond length both are inverse to each other. Next is magnetic nature. if all the molecular orbitals in a molecule are doubly occupied. That is, all molecular orbitals are fulfilled, then the substance is diamagnetic, that is repelled by magnetic field. However, if one or more molecular orbitals are singly occupied, if any one electron is unpaired in any of the molecular orbital, then in this case molecule is paramagnetic, that is attracted by magnetic field. Example, oxygen molecule. Now let us discuss bonding in some homonuclear diatomic molecules. First is hydrogen molecule H2. H2 molecule is obtained by linear combination of two hydrogen atoms. One hydrogen atom contains one electron, that is atomic configuration. In atomic state, electronic configuration of hydrogen atom is 1s1. Okay, so in this way, two hydrogen atoms when combined, then we get hydrogen molecule, and this hydrogen molecule contain two electrons, and these two electrons will go in lowest energy molecular orbital, that is sigma 1s2. So this is the electronic configuration for hydrogen molecule. Okay. Now let us see the bond order of hydrogen molecule. When we use the formula of bond order, and by putting the values of Nb and Na, Nb is number of electrons in bonding molecular orbital. In hydrogen molecule, 2 electrons are in bonding molecular orbital and anti-bonding molecular orbital is vacant. So bond order in hydrogen molecule is 1. This means that two hydrogen atoms are bonded together by a single covalent bond. The bond dissociation energy of hydrogen molecule has been found to be 438 kJ per mole. That means it is highly stable. Now let us discuss molecule for helium atom. Its formula is He2. Number of electrons in helium molecule are 4 and configuration is sigma 1s2 and sigma star 1s2. Since number of electrons in bonding and anti-bonding orbitals are same, so its bond order is 0. So we can say that helium molecule is unstable and it does not exist. Similarly, for beryllium molecule, number of electrons in bonding orbitals are 4 and in anti-bonding orbitals are also 4. So beryllium molecule also does not exist and it is highly unstable. Lithium molecule, number of electrons are 6. Configuration is sigma 1s2, sigma star 1s2, sigma 2s2. Now its bond order is 1 because number of electrons in bonding orbitals are 4 and in anti-bonding orbitals are 2. So bond order comes out as 1. So in this way we can say that lithium molecule exists, and since all the electrons are paired, so it is diamagnetic. Next, let us discuss electronic configuration of carbon molecule. As we have discussed B2, C2 and N2, for these molecules, sequence of molecular orbitals is little bit different. So when electrons get filled in molecular orbitals of carbon molecules, so after sigma star 2s, pi 2px and pi 2py orbitals will fill first, and after that electron will go in sigma 2pz. Now since carbon molecule contain 12 electrons, so configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2 and pi 2py2. Okay, or it can also be written as kk sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2. kk means first shell bonding and anti-bonding orbitals are fully filled. Now bond order for carbon molecule is 2. 8 electrons in bonding molecular orbitals, 4 electron in anti-bonding molecular orbitals. So bond order is 2. Oxygen molecule, total electrons are 16. Configuration can be shown either by this or in terms of kk can be written as. Now let us see its bond order. Bond order of oxygen molecule is 2, since number of electrons in bonding orbitals are 10 and in anti-bonding orbitals are 6. So oxygen molecule has 2 oxygen atoms bonded via double bond. Now this oxygen molecule has 2 unpaired electrons. Look here. Pi star 2px1 and pi star 2py1. So 2 electrons are unpaired. So in this way, according to MOT, oxygen molecule is paramagnetic, and actually oxygen molecule is paramagnetic in nature. Valence bond theory suggested that oxygen molecule is diamagnetic, as according to that configuration it contains all electrons paired up. So this is the advantage of molecular orbital theory. With the help of this we can explain paramagnetic nature of oxygen molecule. Now this is all about this video. In next video I will discuss formation of molecular orbital diagram or energy level diagram and hydrogen bond. Thank you.